This video is brought to you by the ASRock Taichi X299 CLX. This is a brand new X299 motherboard that's been refreshed for the 10 series X299 CPUs. This will be a great pairing with the 12, 14, or even 18 core CPU. The PCIe layout here on this motherboard is pretty great. It's X16, X8, X16, X8. The second X8 slot is disabled if you're going to run two M.2s. That means the M.2s go directly into the CPU, which is not something we saw on earlier motherboards. Overall, it's a pretty intelligent design, pretty well put together. A single gigabit LAN and a 2.5 gigabit Realtek LAN. This is the perfect platform for your X299 based build. It also has onboard Intel Wi-Fi 6, that's 802.11ax, as well as a 20 gigabit, two-channel USB Type-C connection on a module at the rear I/O.
Security. We all want security. We want to feel secure. And maybe the most important place for us to feel secure is in our home. We want home security. And here in the US, we even have a constitutional amendment that guarantees us security in our homes, so we can feel good in our castle. And while you're there, no one can violate you, not even the powers that be, no matter how corrupt they get. I mean, if they claim they hear somebody screaming or if they smell a certain kind of plant, then, well, they kind of can, but they can't like premeditate. They can't just come in with like military force and shoot you and your dog. Well, I just described swatting. They kind of can do that, and they have been doing that. But your possessions, your effects, your papers, as the Constitution puts it, those are secure. You can't have some like KGB raid just to rob you of your possessions. You know what? Asset forfeiture. That's asset forfeiture. And red flag, that's also red flag. But you know what? I'm getting off topic. I'm here to talk about home security. Now, when I moved into this house, I got this ADT Home Security system. And I didn't really want one, but hey, it's here, right? I moved in, it's here. It's not on, it's not active, it's not being monitored, because security, the thing about it is you're almost always gonna have to trade something for it, right? You're gonna have to trade maybe your privacy. We talk a lot about those concepts on this channel. You're gonna have to trade maybe your freedom. A lot of very smart men told us never to do that, and yet we continue to. But most likely, you're gonna trade money. 20 bucks a month for this plan. This is a very basic system. If this were to be magically transformed into a human female like Pinocchio, this thing would put on yoga pants, drive to Starbucks, and get a spiced latte pumpkin spice. And it would text at every stoplight on the way. That's how basic this thing is. I'm not sure what year it was installed either. But I do want to explore ways that I can use it without paying anybody. And that's what I'm going to talk about today. Now, this system is a wireless system. And there's two kinds of wireless security systems. Actually, there's probably more than two, but there's two major kinds. One of them is when you wirelessly contact your monitor or authorities when something happens. When it gets triggered, it uses like a 4G to call for help, right? And that's because the major point of failure in old security systems is that landline telephone, right? You cut that and it can't talk to anybody. So a wireless system is better in that sense. That's not what this is. This is wireless in the sense that it communicates with the doors and windows and motion sensors wirelessly. And that's where this little guy comes in. So this is a wireless sensor. It broadcasts over a radio signal, and that's how it knows open and closed doors. So imagine that this is a really, really insecure little guy, and he's got his friend, the magnet. And when he is pulled away from the magnet, he screams in terror. And when he is reunited with the magnet, he screams in elation. And by determining which type of scream he's doing and when he's doing it, then we can figure out that when a door or window is being opened or closed. We don't really care about this thing. So if you're sitting there and you're thinking, hey, I've got one of those and I get money off of my insurance, I'm gonna keep it, or my homeowners association makes me keep it, so I don't really care what you're gonna tell me about how it's bad. Well, don't worry. Because this doesn't matter. If you have one and it's functional, if you have one and it's non-functional, if you don't even have one, you can still do everything I'm about to tell you in this video, because these little guys really don't care about this thing. Our first step in this process is going to be to figure out what frequency our sensors broadcast on. Now this one has a sticker on it, thankfully, and it has a sticker on the outside, but if yours doesn't have a sticker on the outside, pull it off and check the PCB, because this one has a sticker on there as well. That is a serial number. Googling that immediately took me to a data sheet, and 433 megahertz. 433 is pretty common, actually. That's usually going to be the answer you find here, maybe 350 for some of them. And if you can't figure anything out, you find a number but you can't get any Google results, try the FCC website, because the leaders of the FCC might be busy with, Verizon and taking care of them, but the bureaucrats in the basement are actually testing these devices and cataloging them. And that information is on the FCC website. They actually have a use. And once you figure that out, if you can't find anything, you don't even find a serial number, you can guess and you can trial and error this. 433 and 350 are the obvious starting points. But to do all that, we're gonna need a special tool, because we wanna see what kind of signal is coming out of this thing. And for that, we're gonna go into the security toolbox. I'm pretty sure I have something in here that will probably help us with this. It's been a while since I've been into the security toolbox. A lot of memories in here. It's always the last thing you find in the box, right? A software-defined radio. This thing is going to let us listen to this thing using a computer, which is the last thing we need, other than an antenna to pick it up, is a computer that can run Linux. Now this is a Chromebook. I have Crouton on this, so I'm running Linux natively. I'm not using Chrome OS. This is not the form factor you want to use. You want to use something like a Raspberry Pi, something low power, something you can just stick in a closet. You're not going to mess with it ever again. It's not going to need any human interaction. If you want to run updates, do them over SSH. Although, I will say, adding a battery to this system is really awesome. So you might want to think about that, because every other component runs on a battery. And this thing could survive a power outage other than the external communication. If your internet goes out, obviously it can't do that part, but I'm getting ahead of myself. So get yourself a PC that can run Linux, get yourself a software-defined radio. This exact one and ones like it, it's like 30 bucks on Amazon, plus you get the antenna with it. Now that we have our SDR, we're going to need to figure out how to understand what this thing is saying. Now, you can run a lot of different software. You can run just, you can just listen at 433 megahertz and see the tones, and that's cool. And I did that at first, but it's actually kind of useless, because it turns out there is this great piece of open source software called RTL 433. And you just grab that from their GitHub, make it and install it. It already has all the drivers and everything to drive most of these software-defined radios. If you get, this one is the SDR.com version, if you want to follow along at home. And once you have that, it's actually going to do everything for you. And all you have to do is just run it, and it starts listening. And it can negotiate what's coming out of these things. It's amazing. If you run at a different frequency, you can set a flag and put the frequency in hertz. So for you people that couldn't figure out what your sensors are, you need to just hunt around, you can just fish around the different frequencies with this thing. I think you can even set a range, so you can sort of check many frequencies at once. And so set that up, and then do something with your security sensor that sets it off, and watch it go. So the first step of RTL 433 is you need to install the dependencies. You should be able to do that all with one command on your package manager. There's several of them, but you can look at the README for RTL 433 and do them all in one command. So RTL 433, we got it all set up, ready to test it. I'm standing next to a window with a security sensor on it. So let's just run it. And it found the SDR, looks good. And then we just trigger this thing. Hey, there we go. We've got a DSC contact. Now, you might notice that there are a lot of those. Well, these contacts broadcast in bursts, so I think they do 4 per. 4 open, 4 close. Now, it's a redundancy thing, I guess. So it's not unusual that we're getting that many. That's actually 1 open and 1 close. So we can take a look. This thing's actually breaking it down into the individual values, which is really cool. We've got the time, we've got the device, which is the serial number for the individual device. And you're gonna need to map those for the various parts of your house if you want to tell one from the other one. So, you know, pull out a pencil and paper or your phone or whatever and go around and open and close things and figure out what the device ID is. Closed, so that tells us if it's opened or closed. Was the magnetic field broken or did it go back in? And some interesting ones, battery low, that's obvious. Tamper. So these things, if you pull them off the base, like this one is, the base is glued to the door. If you break that, pull that off, it'll throw a tamper. So you can know if anybody's messing with your sensors. It's got some other tampers in there. It's got a microphone. I don't know if this thing's got a mic in it. I know some of these have glass break microphones. So if it hears glass breaking, it'll trigger. I don't think this one does. But a lot of cool stuff in there. Status, now status, I don't know what status is. It obviously changes between open and closed, so it has something to do with that. But I couldn't find a lookup table for this model for status. If you know anything about that, put it in the comments. So now that we have all this information, what are we gonna do with it? I mean, it's cool to sit here and watch your security system happen around you, but I wanna do something else with it. So step 1, I wanna store it, you know, like big data. I wanna capture everything that happens in my house and I wanna put it in a database. So actually, one of the cool things about RTL 433, you can use the uppercase F parameter when you run it and give it a format that you want it in. For example, JSON. Here we have all that same information, but it's coming in a JSON format. That's gonna be really, really easy for us to ingest. So first things first, this basic version of Linux that I installed with Crouton does not have a database. So I'm gonna go ahead and install MySQL. I'm gonna use that as my database. If you are using Crouton for this, which again, don't recommend, it's got some weird things about setting up servers. There's some special rules, and I'm not gonna go into that, but you'll see some errors in the screen output here. You shouldn't have that problem if you're running it on anything other than Crouton. Now we need to set up a table to store this event information. I'm gonna have a schema for wireless contact table in this project for you. Somewhere in the description of this video, you should be able to find it, or on the Level 1 website. And that is gonna show the wireless contact, the basic stuff you wanna store. I'm not storing the stuff I don't know about. I will store status, but not like the X tamper stuff. I don't know what X tamper is. I have to look more into it. I am not including anything to do, for example, a wireless motion sensor, because that's another piece that you can add to these security systems. You can do a wireless humidity sensor. You can do a lot of stuff. This is just gonna be for the contacts, but of course you can build on that and make your own. So set up that table, and once you have that table set up, now we're going to store things into it. And this is gonna be pretty simple because we can take that output from RTL 433 in JSON and pipe it right into a Python script. This is a really simple, it's so simple that many of you are probably going to criticize it, but we're going to talk more about that in the end. A very simple script to take wireless contact sensor information and put it into our database. Let's take a look at I'll include that as well, but let's take a look at it here. So we have, we import system and JSON because we want standard input, the MySQL connector. Now you're probably going to have to set up the MySQL connector in pip, and I'll run through that real quick here and show you how to do that. Depends on which version of Python you got. This is Python 3. I'm also going to run to import date time because I'm going to do just some very simple time management stuff because of the length of these tones. Everyone rings 4 times. We'll talk about that in a minute. So we have our basic connection information here. Set a cursor for the database, and this is where this event line is where we just pull in from the standard input. So this is coming from RTL 433. We have a JSON formatted information from our sensor. Create a time object out of that, and the event time. So the event time should be right now, but for whatever reason RTL 433 passes that. I don't know if the sensor actually sends that. I kind of doubt it. I think it's probably coming from RTL 433. Here, the last second variable, we have a date object where we're just removing 2 seconds. Now, the reason I want that is because this event does 4 tones per open and close. And that might be different for every brand of broadcaster. I don't know. The sensor, I'm not sure how that works. But in this case, I don't want to store all 4 of those tones. I only want to store 1 of them. So the way I'm doing that is after I get the first tone, I'm checking to see if that same exact record already exists for 2 seconds, because it takes about a second to run through those things. So then we're doing a select here, and this tells us, do we have a duplicate of this record in the database? This is our 2-second check right here. And we just want to make sure that we don't insert it again if we just got that same tone. This is one of the 3 that come after it, so ignore it. If we don't find that result, then we insert this into the database and commit it, and that's it. That's all there is to this thing. And now you have the records that's coming from your or your broadcast sensor into RTL 433, then into this script. Now it's in your database. So you have a running log of everything that's happening in your house. Now, one thing that we need to talk about right here. I don't have super close neighbors, but I have noticed some stuff bleeding in. Actually, while I was filming this, I just saw a humidity sensor come online. So you might have to have a master list of your devices and only insert your devices, especially if you live in suburbia and everybody has cookie cutter homes with the same security system. So just keep that in mind. Now, if you're security minded and you've never messed with this stuff before, or maybe you're just larcenous, there's probably some bells ringing right now and you're thinking, hang on, that thing's broadcasting with no encryption and no handshake and no keys. It's just blurting out everything that's happening in your home. Yeah, it is. There's nothing to stop anybody from listening to your security system if you are running these sensors. Now, there are some companies that advertise rolling keys or some kind of encryption. It's out there, it exists, but not these ADT sensors. And I don't know how old these are, but you can buy similar ones on Amazon. I'm very confident they work the same way. So it's not a great security situation. It's not any kind of security situation. Now, someone taking advantage of that, how likely is it? Well, I can think of 2 scenarios off the top of my head, right? So the first one would be a replay attack. These cheap SDRs are only going to listen, but you can get them that will broadcast, or you can build your own. And because you're getting the exact tone, for example, you're getting my exact open door tone, and you're getting the timing of it for the 4 tones, you could replay that. You could send my security system a tone that says the front door is open. And if you waited till I went to work and my security system was armed, and you did that 4 or 5 days in a row, how long do you think before I just turned it off out of frustration? 5 false alarms, it would drive you crazy. So that's something to think about. That's a little bit high tech, a little bit lower tech, and still probably not super likely for the common meth head who's breaking into your house, is a jamming attack. Because just by listening, I know exactly what frequencies I need to block in order to blind that base station, right? So if I'm jamming 433 as I kick your door in, the open door signal is never going to get to the base station. So, now there are also security base stations, not this one, that will have anti-jamming. But the way they handle it is to send you a push notification because they don't want a false alarm on every little thing. So you're gonna get a message on your phone, it's gonna be like, I'm being jammed, do you wanna activate the alarm? If you miss that for whatever reason, then you're still gonna get broken into. It's not gonna help you. So in terms of security, it's good to think about. Those are unlikely scenarios, but again, they're selling you security and you're not getting any with these sensors. But ignoring all of that, now we have our sensor going into a database. We have everything in our house being monitored at all times. Now let's start talking about setting up rules, right? Now your average security system, it's just on or off, and if something happens, it calls out or whatever. But we can get more complex because we have a whole computer to work with here. I'm not gonna talk about how you get notified. There's too many ways to do it. You can do push notification, you can do RCS, SMS, you could email yourself, you could tie this in with home automation somehow. You could put a 4G on this thing and call out. You could do so many different things with it. I'm just not gonna go into it. So I'm gonna say, hey, we're gonna write a little script, a monitor script that's gonna check for things. And I'm just gonna say, here's where you notify yourself. So work that out on your own. But let's take a look at a script now. It's also important to note, this script doesn't have to be on this computer at all. It just has to be able to connect to the database. It doesn't have to have anything to do with what we just did. And I'm actually gonna switch over to PHP from Python to illustrate this can be completely different as long as you can connect to this database. But also because I'd rather work with dates in PHP and I'm kind of lazy. So let's take a look at that. We're gonna look at 3 scenarios of monitoring our database that we just set up. Now with this version of Crouton, again, I did not get PHP out of the box. We will look at installing that from a package manager. Pretty basic, just remember to install PHP MySQL while you're at it because we have to connect to a database. And from here, so the strategy, the way that we're going to monitor this is through cron. So we're gonna use the Linux cron every X number of minutes. In my example, we're gonna use 5 minutes. So the idea is the Linux cron is gonna run this thing every 5 minutes, and then we're gonna look at the past 5 minutes of time. And during that 5 minutes, we're gonna determine if anything happened that we need to be notified about. 5 minutes is kind of long maybe for a security system. You could run 1 minute, you could run 30 seconds, whatever. Just be aware of how long this thing takes to execute on your hardware, and especially if you're gonna use external APIs. So let's take a look at this script. First of all, we're gonna define a start and end time. Now, you kind of notice here, the only thing I'm doing weird here is I'm setting the second values. 0, 1 for the start time, and 0, 0 for the end time, because I want to get exactly well, actually not a 5 minute, a 4 minute, 59 second slice. The reason I'm doing that is because I don't want any execution lag. When cron triggers this exactly on the minute, I want to make sure that I'm looking at only exactly on the minute. The reason I'm doing 01 is I don't want that to repeat. If I do 0, 0 and 0, 0, then an event that happens on 0, 0 of that end value will trigger again on the next cron. I don't want that. So we make our connection to the database, and then we're going to have 3 functions here. And these 3 functions are going to be how we measure what's going on. Alert on open is our most basic. So we're just going to say, did this particular device open during this 5 minutes? So in this example, I'm thinking of something that you always want to know if it gets opened. For example, a gun safe. And again, you can buy these sensors. If you don't have a sensor on your gun safe or your cookie jar or whatever it is you want to measure, just go buy some, because you can add infinitely to this setup. So all we do is query, and if we came back with a open state, closed status equals 0, and a device ID of the gun safe, then yeah, that means that during that 5 minute time, our gun safe was opened. And so we will send a notification and say, hey, the gun safe is opened, and the kids are alone at home, and you're going to prison. Next up, we have, I've been thinking about how I'm gonna do this that's advertiser friendly. Let's say you have a teenage daughter and she's really, really popular. Then you might have trouble with her sneaking out. You know, she wants to go, she wants to party, and you would prefer not to have grandkids. So you wanna stop that from happening. So we're gonna add a little complexity to this rule. We're gonna say, hey, you know, during December, January, and February, there is no reason that bedroom window should be opening. And there's definitely no reason that it should be opening between midnight and 6 a.m. So you see here, we're just gonna check these date values. And if the date value, the start date, is one of those 3 months and it's between midnight and 6 a.m., we know something's up. We're gonna have to do something about it. And so other than that, it's the exact same query. You look, you check, did anything happen? If 5 minutes ago she made the break, she's out, you gotta go track her down. Do something about it, because diapers are expensive. In our final example, we'll actually look at some stuff that happens outside of our 5-minute slice. In this case, we wanna see if something has been open for too long, and we define what too long is. So here I've set up an array. This would be an array of all of the openings in your home that you think shouldn't be open for a certain amount of time, like external doors, for example. Why would an external door need to be open for 20 minutes, or a window? Window makes a little bit more sense, but hey, for this example, we're gonna pretend that we don't like fresh air. So we set up the external windows array and we give it some values. These are device IDs of our doors we wanna monitor, or the windows we wanna monitor. Then we set a value for too long. This is gonna be in minutes. So this is how long we consider to be too long for a window to be open before we're told about it. From that point, we will just query the database as before, but we're not going to look at start and end dates here because we have no idea when this thing was opened. Because again, we're looking at a 5-minute slice and this is a 20-minute measurement. Instead, we're gonna order it descending and limit 1. So we're getting the last thing that happened, the last event that happened to one of these windows. And then if that last event was an opening instead of a closing, then we know that this window is still open. And then we have to check the dates. So we're actually looking at the start and the end date here. The reason we're doing that is because we only want this notification to send once. If we don't look at the end date, then this notification would send infinitely on every cron until that thing was closed, which is maybe what you want. Now, a quick reminder, and hopefully this is obvious to you, but don't monitor other people's security systems. Yes, I know that it's easy, and I've just showed you how, but that is not a good thing. I'm not sure if it's illegal, but it won't turn out like you expect it to. I promise. Hey, Sarah, it's Ryan. No, from the social anxiety support group. Yeah, no, I'm doing great. Yeah, it's been like 2 days since my last panic attack. Yeah, it's going great. That's not the reason I'm calling. The reason I'm calling is because your back door has been open for like 5 hours. And I worry about your safety. How would I know that? It's like an intuition that I have, because I can't, no, do not call the police. Listen, I can explain this. Sarah, I love you. Now, we talked about this code not being production ready, but maybe you actually want to run this in your house. So what do? Well, I'm going to tell you something that I usually don't do myself. Go to the level 1 forum. Now, I know what you're thinking. It's a horrible place. No one ever goes there and comes out the same. But here's what you have to think about. The small group of people and their negative traits that keep you away from there, the gatekeeping and the signaling and desperately wanting to lecture you, those are all things that make them very valuable in this instance, because they almost can't help to not give you advice and help you with things. So go there, make your case, and they'll fall all over themselves to help you build a production-ready version of your home security monitoring system. And I might even drop in myself, but probably not.